Okay, so once you've kind of got the idea of how do I convert MATLAB speak into numbers, then in theory you can go ahead and convert regular math into MATLAB, which is kind of the whole point. But for me, it makes more sense to kind of do one step at a time. So generally, people are okay with being like, oh, okay, so I can do that. 3 squared plus 5. And they're like, yay. Okay, and as always, you kind of want to make sure that you know what the answer is supposed to be. Plus or equals 9 plus 5 equals 14. So is it supposed to be 14? Yes, it's supposed to be 14. I'm amazing and kind of brilliant. Now, just so you know, the answer isn't any different if I put spaces or don't put spaces. I'm getting the same thing. I just like to put spaces in ways that helps it make sense to me, but there's no difference at all. Okay, so there you go. It's beautiful. Now here, x equals 3 to the 3 plus 1 plus 5. And you're like, awesome, I did it, I win. Okay, but this is again why you need to go in and put in the answer and make sure whenever you're running code, it's very, very, very silly to write code, hit enter, and be like, yay. You always want to have something to test it against. So like in this example, I have 3 to the 3 plus 1 plus 5. So I need to be like, okay, so what is this really? So it's 3 to the 4 plus 5. Now 3 to the 4 is 9 squared, so that's 81 plus 5, which in theory is 86. That is not what I got. Okay, and you're like, but it should do the 3 plus 1 first because there is a big space here, but that's not how MATLAB works. MATLAB doesn't care that there's spaces there. Really what it cares about is the order of operations. So what it's doing is 3 cubed, which is 27. Okay, so kitties are having a fight. So if you're kind of taking notes here and you're like, what did this actually do? So we can be like, what? So this is a common mistake. And you could be like, what we actually coded here is, and if you want to see how to put in these cute little things, you can go to insert equation, and that's kind of what I've been doing. So actually what you have here is x equals 3 cubed plus 1 plus 5. Okay, so that's what you have here. We need to emphasize that we need to do the 3 plus 1 in the exponent before we do the 3 to the part. Sorry, I don't have a better way to say that. So remember, this is what we're trying to do. Stroops. Okay, so when we look at kind of what we did, whenever we did this, we're like, okay, we have the 3 plus 1. Now, even though we didn't write it like that, let me do it here. We did the 3 plus 1 first. So whenever we see 3 to the 3 plus 1, our brains did the 3 plus 1 first because we know that's what we need to do. So if it helps to rewrite the equation with parentheses for your brain, that can help. So if you're kind of struggling with this and you're like, I keep getting the wrong answer and it's always stupid and math is dumb, try rewriting things with the parentheses so that whenever you go convert it to code, you get the right answer. And there's the 86 we were looking for. So does that help? Hopefully. Okay. Okay, so now it can obviously get much more complicated. For example, let's try a new section. So new section break. Okay, so let's do more complicated-y stuff. So what if we had more of a quadratic equation? Or the quadratic equation. Okay, so say we had something like, what if we had x squared plus 5x plus 6 equals 0? Okay, now we know that x plus, 2 times x plus 3 factors that out, in theory. Yes. So that means x is equal to -2 or x is equal to -3. Okay, so those are the answers we're looking for. Now, clearly, computers, well, okay, they can solve this problem, but we're going to pretend that computers can't solve this problem yet, although they clearly can. We're just not doing that yet. So let's say that if we're going to have a computer solve this, we're going to have it use the quadratic formula. So let's solve this using the quadratic formula. Now, I could have just set up a quadratic formula in general, but it's, again, always good to start with a problem that I know what the answer is in advance so I can make sure that it's working. Okay, so as a reminder, the quadratic formula is, what is it? I don't remember. No, I do remember. I'm just trying to remember where this thing is. All right, x equals, it's a fraction, -b, and there should be a plus or minus. If you can't find it there, it's over here somewhere. There you go. Plus or minus. No, wait, what'd you do? Plus or minus the square root of, no, I want the actual square root sign. The square root of b squared minus 4ac all over, come over here, 2a. Okay, so that's the quadratic formula. So let's give this a shot. Spoiler alert, I'm gonna do it wrong. Okay, this is just in case you're shocked. All right, so let's go with, in our case, what do we have? A is 1, B is 5, and C is 6. Okay, so A is 1, B is 5, and C is 6. And remember, if we don't want to have to see that every time, we can just go in here and be like, chirp, 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 and the semicolon suppresses the output so we don't have to look at it. All right, beautiful. Now, there's no plus or minus in Matlab. It's a function, so I can only have one output at the moment for putting asterisks next to everything I say, it feels like. So let's just say x equals -b plus the square root of b squared minus 4ac over 2a. Beautiful. That's not the answer. Okay, now I kind of threw something up there. I just used a square root function even though I never really talked about it. And that's the thing with Matlab. If you want to use a function, guess at what you think it is, and that's probably right. So square root is probably either square root or squat, or, yeah, see, I put in squat, and it's like, did you mean squirt? And I'm like, oh yeah, or squirr, and it's like, well, I don't even know what you're trying to do. You can also, if you're like, well, I think it's square root, and you're really kind of sensitive about it, squirt, if you type in help squirt, it'll tell you for sure, yes, this is a square root, just in case you were scared. It's okay to be scared. All kinds of things can be scary. I'm scared of quesadillas, or I don't know why I said quesadillas. So you can put in here, you can click documentation, and it'll tell you all the cool things the square root function can do, but just basically it returns the square root of, and you don't have to worry about the rest of it, but just returns the square root, and then you can ignore what the rest of this says until you get to a point when you're like, why am I not getting the answer that I want? And then you have to start reading the rest of it and figure out why. But right now I'm getting the answer of about, well, in this case I was doing the square root of 3, which is about 1.7, so it's doing what I think it needs to be doing. So you can just kind of play around with other functions later. But this is not the answer that I wanted. This is not the answer. So if you're curious, this is what I actually coded. So if you think about it, and this is kind of why we talked about order of operations, because I want you to be able to kind of look and be like, why is my code not working? So why is my code not working? Because what you actually coded is you have x is equal to -b, and it's adding the fraction of the square root of b squared minus 4ac over 2, come here, girl, over 2, and then it's multiplying the whole thing by a. Okay? So look at this and look at this, and do you see why this is this and not what we want it to be? So essentially, if you're thinking about order of operations, it's doing the square root, then it's dividing by 2, then it's multiplying by a, and then it's adding the negative b in there. Okay, so another common mistake is to get the numerator right, but not the denominator. So, for example, you'll see students that'll do this. They'll be like, x equals, and they'll be like, okay, I know the top has to have the square root, or the parentheses, square root, b squared minus 4ac over 2a. And again, this is not the right. Is it giving me the right answer accidentally? Okay, well, that's a mistake. I mean, it's not a mistake, but it's an accident that it's the right answer. It wouldn't work if we had a different b. It's because the a, it's because the a happens to be 1 here. But what this really is so what this is actually doing is the x is equal to, it's doing the numerator right, so negative b plus the square root, hotkey, no, oh yeah, square root, I'm so sorry, b squared minus 4ac over 2, but then again, it's multiplying by a out front. Now you can't tell in this example, unfortunately, because I picked a as being equal to 1. And so this is another problem, of course, with programming, is you might pick a bad example to test your code on. So we'd be like, awesome, this code works. But then if you potentially go in there and you pick another question, like let's say if I multiplied everything in here by 2, I should still get the same answer, right? So if I go 2, 10, 12, I should still get the same answer. And now I'm getting 8. I should definitely not be getting 8. I should still be getting the correct answers. So if I had 2, 10, and 12 is what I'm saying. I should be able to factor out a 2 and still get negative 2 and 3. Here I'm not. Okay, so what I really need to do, so I need to make sure that I'm putting everything in the numerator in parentheses, but also everything in the denominator. So we're gonna do this one more time. X equals negative b plus the square root of b squared minus 4ac all over, and see how I'm kind of spacing things out? I'm only doing that to make it easier for me to see. And there's the negative 2 that I wanted. So even though I kind of separated it out and multiplied everything by 2, I am still getting the right answer. Now there's actually 2 of these, remember. So there's x and x2 with the minus sign. So this should give me the negative 4 or negative 3. Math is hard to remember. Yeah, negative 3, negative 2, negative 3. And it does. Now let's go put these back to the original values and make sure. So we have a 1 and a 5 and a 6. And there's the 2 and the 3. So those are the answers that I'm really looking for, which makes me feel good because I'm finally getting the kind of stuff that I need to be getting. Okay, so again, whenever you're doing these things, as you're getting started, it's really common to make these kinds of mistakes. I've also seen people be pretty successful by doing stuff. So again, just kind of as a reminder what we're trying to do, I'm going to pull this little girl over. Come here, girl. All right. Sometimes I'll see people that'll say like, so top part equals, and they'll be like negative b plus the square root of b squared minus 4ac. And then they'll be like bottom part equals 2a, and then x is top part divided by bottom part. And you know what? That is 100%, here, I'll just suppress those. That is 100% okay to do. Matlab doesn't care how many lines of code it takes you to do it. I mean, your boss might eventually, but this is not taking up any extra time to do, and it's maybe making things a little bit easier for someone else to come back and see what you're doing. So it's not a terrible idea, and if it helps you see things better for the moment, I mean, there's no problem doing that. Code that works is code that works, and code that works that you know what it's doing is infinitely better than code that works and you have no idea why. So in general, stuff like that is always good to play with. A couple of things. In general, Matlab is pretty obvious, with functions, obvious and not obvious, using functions and stuff. So like if I want to do something in Matlab and I'm like, okay, so x equals the sine of, I'm just going to say pi. It's pretty straightforward. X is sine of pi. It's exactly what it's supposed to be 0, but it's super duper close to 0 for reasons. Okay, maybe I should just explain what this is. Okay, so this is 1.22. This answer, I'll just say this. Okay, this answer means 1.22 times 10 to the negative 16. Hi, Maddie. 10 to the negative 16. And basically, it means super duper close to 0, because computers are weird and they can't do certain things, and it's way beyond the context of this course to get into, but for practical purposes, just be content that that means 0. And if you want to find out more, there's plenty of information on that. So you can use functions that you think may or may not work, and they generally will. So I guess my suggestion is, if you think it's going to be a function, guess, and you're probably right. The only two primary, so like sine, cosine, tangent, max, min, although we're not really going to get into those for a while, but like sine, cosine, tangent, square root, squared, I'm trying to think. The only things that are, the only ones that are really weird are the exponents, like the e to the xe thingies, like e, oops, that's not an e, like e to the whatever, and logs. So if I wanted to do like just x equals e to the first, so just x equals, this should be, I can't spell, this should be 2.7-ish, right? Because e is about 2.7. But if I say x equals e, in code, sorry, if I put this in code, and I try to run it, it's like, you're dumb, stop it. You've got to be kind of careful with, dismiss. You've got to be careful. So whenever you see this, that's because e is not a function. You're like, maybe it's e, but no, it's not that. So just the things that you got to be aware of, e is actually exponential, and you have to say it's e to the 1, okay? So that's how you go. If you need e to anything else, then it's e to the that. If you need e to the anything else, it's exp to the anything else. So if you need, I really should control shift E from now on. If you need, x is equal to exponential e to the, 4 plus 5, then your code would need to be exponential 4 plus 5. And that's just the way it goes. And again, as a reminder, what this is that you're looking at here, this answer means 8.1 times 10 to the third. Okay, so that's what that means there. Logs are also dumb. So in theory, like log of 10. So if you do log of 10 on your calculator, it should be 1 because 10 to the 10 is 1, so log base 10 of 10 should be 1. But if I do this in Matlab, if I do x equals log of 10, it comes out as something really weird. And that's because, I can't spell, that's because in Matlab, the log function is the natural log function. And I'm going to say this is because in 1425, when people invented Fortran, okay, it wasn't 1425, it was like in 1960 something, that's how they did it. So we just kept doing it that way. But, so just in Matlab, the log function is the natural, I can't spell, the natural log function. So like, if you want to do a log base 10, you have to do it this way. And if you want to do a log base 10, it's log base 10 of 10. And then you get the one that you wanted. If you wanted to do the log base E of 1 is 1, so I mean, that's good. Sarah, I'll put this in here. So if you wanted the natural log of e to the 1 equals 1, and you can test this out. And you can, why do I have two a's? And you can confirm this by doing that. By saying the log of the exponent of 1 is 1, but again, so normal log is log base 10. There's other logs out there, but it's not as easy as saying log 3 is log base 3. If you really care, again, you can go into help log, and it'll tell you log is the natural logarithm. If you actually type in ln of something, it's going to be like, what are you talking about? That's not a thing. So log is the natural logarithm. There's actually a log 2, there's a log 10, there's log other things that you can learn all kinds of things about if you desperately want, and that's the beauty of the help function. But just kind of as a warning, most things in Matlab are absolute value. So absolute value does what you think it's going to do. Like absolute value of, I was trying to think of other examples. Absolute value of -5 gives you 5. Anyway, we'll talk about functions another time, but just in general, if you're trying to do something in converting math to Matlab and you're trying to do something like, most of the stuff does what you feel like it's going to do, except for the stupid exponentials. So aside from the exponentials, everything is pretty straightforward. So aside that, you should be in pretty good shape. So the exponentials are dumb and the logs are dumb. Sine is always in radians. There's ways to get around it, but we can talk about that another time. And when you get weird answers that say e to the whatever, that just means times 10 to the whatever. So always test your code on stuff that you think you should have the answer to, just to kind of make sure that you know what you're doing. But I mean, this should be fun. Play around with ideas, play around with stuff, and just see if you can get it to work. Should be fun.